Okay, so here I've said 0.7. Now, when you're doing when you have something like this and you're taking a measurement, I do give a little bit of wiggle room. So typically I will give, let's say, a variance of 0.1, okay? Or if you think of it, it's like a tenth of a milliliter. So meaning if you had said 52.6 milliliters or 52.8 milliliters, that would also be an accepted value. Okay, so give this a try. So remember, here are the larger lines between 6 and 8. Count how many there are. Make sure you know what each line represents. So you're reporting these certain digits and one uncertain digit. So you can pause the video, you know, zoom in if you have to, but take a look at this and give this a try. Okay, so let's take a look at this. Your certain digits that you should have should be 6.6. So meaning here's 6 and here's 8, and actually you can see this larger line right here is a 7, right? So we have 1, 2, 3, 4, 5 to 7, right? So that means that each line represents 0.2 milliliters, right? So it's like 0.2, 0.4, 0.6, 0.8, 7. 7.2, 7.4, 7.6, 7.8, 8. So this line here, and you notice that the bottom of the meniscus is very, very close to this line, but I would say it is still higher than this line right here. That is our 0.6. So 6.6 is actually from this line directly. Now your uncertain digit that you are reporting, so I would say this is slightly above. So I put this as being a 1, 6.61 milliliters. If you said 6.62 milliliters or 6.60 milliliters, those are also accepted. Very nice. Now give this next one a try. So again, make sure you are counting out all of the lines in between, knowing which one is which. Pause the video and give this one a try. Okay, so for your certain digits, you should have here 11.5. Now, I'm kind of helping you out here by showing how many decimals to do here with these little blanks. But you're probably wondering, well, how do you know how many numbers to write down? It depends on the lines and what each line represents. So here we have 10, and here we have 15. So if you count out the number of lines that are here, we have 1, 2, 3, it's hard to see, but there's another one there, 4, 5, 6, 7, 8, 9, 10. There are 10 lines in between the 10 and the 5. So that actually means that each line is representing 0.5 milliliters. Like notice how every graduated cylinder we've looked at is a little bit different. So here we would have 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, and 15. So the number that we are certain of is the 11.5 because that's what the line represents. Now you always have to report, so these would be our certain digits, and you always need one uncertain digit. Now here, I would say that that's pretty close, that's pretty right on the line to me. So I actually put that as being a 0. So if you put 11.51, that's also acceptable, right? Or if maybe you saw that this was you thought this was a little bit below and you said 11.49, that's fine as well, right? Or 11.51. So hopefully that is making sense. So always you are reporting certain digits and one estimated uncertain number. Okay, so thermometers work in exactly the same way. You want to if you think about it, right, thermometer is really a tiny little cylinder on the inside of that glass. So you want to determine the temperature by making sure you are reading it at eye level again, and you're reading the bottom or top, depending on what the liquid is, of the meniscus. So you are recording all certain digits and one uncertain digit. You're going to notice that anytime you are reading from a cylinder shape, that's what you will always be doing. You do the certain digits with one estimated uncertain digit. So, a couple of other tips when you are using a thermometer. So this is more if you are actually using this physically. Usually virtual labs will have this already done for you, which is kind of nice. So when you have a thermometer that is inside of a flask, so it doesn't matter what it is. It could be a beaker, it could be an Erlenmeyer flask. It doesn't matter what the container is. But you want to make sure that the thermometer itself is in the liquid, not touching the glass at all. So it's kind of suspended, only having liquid surrounding it. This becomes very important when you are heating up your liquid or cooling your liquid down. The reason why is if it's touching the glass, you're actually going to be reading the temperature of the glass. And actually, you'll learn this later on, later on in your science if you continue in chemistry, but every type of material has a different absorbency for temperature. So meaning the glass that this beaker, let's say, is made up of will absorb a different amount of energy and have a different temperature reading than the water inside. So you have to make sure that you are reading the proper item that you need. Like we want the temperature of the liquid. We don't want the temperature of the beaker. Okay, so same deal is happening here. Remember, you're doing all your certain digits and one uncertain digit. So give this one a try. Again, pause the video and see if you can take these readings. Make sure that you know what each of those lines represent. Okay, so hopefully you've had a chance to try this out. So we have here 80 and then 90. So if you were to count in between, there's actually 10 increments, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of those spots is essentially a 1, right? So it's like 81, 82, all the way up to 90. So if you're looking at this, right, our certain digit is this line right here. So our certain number should be 87. So this value here, remember there is a little tiny meniscus there. It's hard to see. So I have this as actually being a 0.4. It's very common. It's very hard to see that little tiny meniscus. So if you said, again, 87.5, that's cool, right? 87.3, I would also accept. So usually a variance of a 0.1. Over here, your certain digit is 35, and actually I would say that this, you can actually see the top of the curve there, but the bottom I would say is pretty much bang on that 35, so I would put that as being a 0. But again, right, that variance, so 35.1 or 34.9, that is accepted, those are accepted values. Okay, what about when we're using a scale, okay, or a balance? Now, for this one, you're not going to have an estimated number. The scale reading that you would record is whatever the readout is. So some scales actually will record to 1 decimal point. Some scales will record to 2, or some won't even record decimals at all. It'll just say a whole number. So usually the more decimal points that a scale records or is able to output, the more expensive the scale is. Okay, so obviously when you're doing when you are doing virtual labs, right, whatever the reading is, you record down. Just so you know, the ones that we have at our school record to 2 decimal places. So, but it's important to note, let's say you're doing a lab in person and the reading was 5.00 grams on the scale. You must write down 5.00 grams. For some reason, students like to just say, oh, okay, it was 5 grams. But when you're doing your report, your lab report later on, 5 grams is like a rounded answer. Well, was it 5.11 grams and you rounded it to 5? Was it 4.99 grams and you rounded it to 5? Then you're not sure. So you always must record whatever the number is. It is what it is. So that way for sure we know, okay, it was 5.00 grams. Remember, going back to this also, it improves your significant digits, right? We have 3 significant digits here. So a couple of rules. So make sure before you measure anything that the balance is level. So what does that mean? Make sure there's not like a textbook underneath or, you know, some papers. You want to make sure it's flat on the surface of wherever you're measuring it. So on the lab bench, let's say. Make sure you are not weighing it when it has a number already. It should be reading 0 before you start putting something on top to weigh it. You never want to weigh something directly on the balance pan. So balance pan is like this metal top here. So usually we'll add a piece of paper or a piece of plastic. So it's almost like a little dish. We call it a weigh boat or a weighing paper. It's like a little plastic dish that you put on top. So you can put your, let's say we want to measure out some powder or, you know, some chemical that's in a powder form. We don't want that to spill all over the place. We want to keep it inside of a container so we can use it to put inside of a beaker or something else later on. So you want to make sure that you're doing that. If you're weighing something that you had that was hot or cold, you want to make sure they come down to room temperature before you weigh them. And of course, if something spills, if it's something that you are able to clean up, like if water spills, you know, obviously just clean up the water. But if any chemical spills, please let me know, and then we'll have to clean that, of course, right away. That way the next person that's coming in has a nice clean scale when they're going to start using it. So I hope this helped you with starting to look at measurements in science. Hopefully this helps you not only for chemistry, but for any other science course that you are doing. Take care.